Okay, so hello everyone. Again, we have still 5 minutes, so let me know if you have any questions in the meantime. I have already uploaded the new slides into Avenue for those who would like to open the slides while in the lecture. Let me ask, is there anyone still with problems for Lab 0? For Lab 1, in fact, officially didn't start yet, so don't worry too much, Zawhan. Like it's starting beginning next week, and the questions themselves are not very hard, so they might take some time from you to develop. And again, if you have questions, seek help from the office hours. We would keep the same office hours schedule for the remaining weeks as well. So every day from 10:30 to 2:30, you can seek help, and also during your lab session, there will be 2 TAs to help if you have any issue with Lab 1. Should I wait to clone Lab 1 for the stuff that's gonna get fixed? Okay, so as Zawhan is saying, I will send out an announcement today on Avenue, or maybe I just also email everyone to make sure everyone looks into it in a timely manner. They are very minor 2 fixes, so maybe I'm still exploring what is the easiest way for you guys to get this into your own repo for those who already started cloning Lab 1. Is it better to just I do it on my side and then you pull, or I ask you to do it yourself? But it's in fact like a couple of lines change, so it's not a big deal. Don't worry too much. I would say you can start developing your lab as usual, and those changes will not affect any work you do, so you don't have to repeat anything. So don't worry about it for now. Okay. Kurt, so are you talking about like there shouldn't be any error, because it's like modifying any file. Like the Git works exactly the same way. If you modify the the questions.c or the test cases or the make file, it's just modifying a file, right? So I would say that you shouldn't be getting any error, but maybe we can look together during office hours for what error is that. It could be the conflict between line ending on run.shell. I see what you are saying, Anna. I'm not sure that might be a reason, but I would say let's not worry about this for now, right? It's if you have issues, Kurt, fixing it yourself, then maybe we can talk after the lecture and see, or during the office hours and see what is the problem, right?
When are your office hours?
My office hours, like myself office hours are in Tuesdays after the lecture until 3, but I also drop in regularly, especially in these first weeks, to make sure you guys get enough help during the TA's office hours. So TA's office hours are 10:30 to 2:30, and yeah, you will see me frequently going there and check if there are questions that are not handled. Also during lab sessions, I kind of drop from time to time as well to make sure if you need anything, I can address it. Also, you can email me if you have an issue that you think TA cannot help with, and then we can take it from there.
Okay, thank you.
Yeah, thanks. Okay, so it's 31. So let's start. We'll continue what we started last time. I guess it's a very important concept. So I'm going to reiterate, maybe go a little bit a step back and start from what is a local and global variable. Just a brief revision of what we have done in the last 10 minutes of the previous lecture. So we said a local variable is a variable that gets defined across a certain block of code. This block can be a function, and then we say that this variable is then a local to this function, or it can even be within a block of a function, like a for loop or an if statement, and then this variable will be local only to this block. It will not even be visible outside the block for the whole function. On the other hand, the global variable is a variable that is defined outside any function in a file. And this is called global because you can use it, you can read it, you can write into it from any function in the same file. Good. So in this example, we have by defined outside the main. So it's a global variable, while m, on the other hand, is defined inside the main. So it's local to the main. Good. Good. So we have already covered this. And then we said a very important thing is that you are not generally recommended to use global variables. And they said, in fact, it's a rule into SH4 is don't use any global variables unless you are asked to do so. The reason for this is global variables are get defined into, maybe it's a bit of detail for you, you don't need to care about, but it's get defined in what we call a heap. It's like the general memory, right? And this general memory is very limited. So the more variables you define globally, the more memory space you are going to use, because you have to keep this variable for the whole program execution, right? On the other hand, local variables, as we have seen for the my square, my mean square function, x and y and z, they only get defined once you enter the function. And once the compiler or the hardware finish executing this function, those memory spaces get freed or destroyed, which means you use the memory only when you need it, right? And if you enter the function again, it get defined again, and then once you exit it, they get destroyed again. So local variables are more efficient from the memory perspective. Another reason why we shouldn't be using global variables is they are sometimes confusing. For example, assume you have a big project that has 200 variables. If everything is global, while in fact you only need to use them within specific block, if you change this variable in another function that is not supposed to change it, it's very hard to track where the change happened, right? On the other hand, for debugging purposes, if you only define variables when needed, then if this variable creates a problem, you are able to check whether this variable is like causing this problem in this specific line of code. So you narrow down the possible alternatives of a problem once you have a problem. Good. Okay. So we took some examples last time, so maybe no need to go like in detail about these, but let's briefly discuss them. We said here alpha in the left side. So I just use my pen. So here alpha is a global variable because it's defined outside everything, which means you can use it in any function, including this square function. So this code should be okay. On the other hand, if you define alpha inside the main, if you go to the square and you use this, you will get a compiler error. Why? Because inside the square, the compiler or the hardware is jumping to a different memory space where alpha does not exist, right? So here, if you have this main and this is the square memory space, alpha is here. While you try to access it from here, right? On the other hand, the memory here looks like the following. This is the main. This is the square function. There is an outer world where alpha is existing, right? That means alpha can be used here, excuse me, and can be used here. On the other hand, in the outer world here, there is no alpha. So if you try to access it here in the square, it complains that's not defined. This makes sense? Because this visualization might help explain this thing. So then a question, if I want to use alpha inside the square, what should I do? What do you think? Because I want to square alpha. So what is the right way of doing that if I don't want to use a global variable? Pass alpha in, exactly, Arjun. So you simply just pass alpha as an input parameter here. So you change, so you change the definition of, what did I do? So you change the definition of the square to take double instead, and you call it anyway, anything like alpha x, y, doesn't really matter, call it x. And then here, when you call square, pass alpha in. By doing this, you are able to square, but here instead it will be double x. It's x multiplied by x, and then it will return the square of the alpha. Good. You can touch it if there's a question, call from pass it to the parameter. Okay, thanks. You are all saying the same thing. Good. And this took us to the scope. When we, like the word scope, and like just to give you the terminology, the scope is the domain in the code that the variable is defined. Local variables have a limited scope, which is the block. Global variables have the scope of the file. So we have what we call file scope, for example, where a global variable will be defined across the whole file in any function in that file. We have block scope, a local variable within a block. The for-f is going to be only local here. And then there's a function scope. If you define a variable that is inside a function outside of any block, so for example, outside of an f or for, it will be visible within the whole function. It's just a terminology, right? Excuse me. Then another important thing that we didn't touch in detail in the previous lecture is how this scope affects the storage duration. We said in the past 2 minutes is that if there is a variable that is local to the function, this variable only get defined in the memory, get allocated a space in the memory once you enter the function by calling it, and it get destroyed at the end once you return. Good. So the storage duration of a local variable is the duration of the execution of its local block, whether it's a function or not, right? On the other hand, global variables, as I said at the beginning, they are existing for the whole file, so you have to keep them longer in memory, and this is one disadvantage of a global variable. Good. So now, I told you, and this is the thing that we concluded with in last time, what if I want intentionally to keep the value of a variable across different calls of a function, right? Is there a question? Okay, so why do we want to do this? You want to do this, for example, because maybe you want to carry on a state from function call to another function call. Let's take an example to make this clear, right? So let's forget about all the theory now. I like to go through examples and then explain the theory there. So assume I have a function that I call anything, int function, and then int a1, and it takes an integer value a1. And then I do something inside this function, which is I define a variable and then another static variable. I increase both variables, and then I return a plus b plus c. And then I call this function inside the main here by passing 2 into it. And let's see what would be, if I'm printing the value of the return, what would be the value across different calls. So here, see that we are calling function a inside the for loops is being called 3 times, 0, 1, 2. And let me just move the video thing here. So let's go through an iteration one by one and see what happens for the b, c, and the return value. In the first call, because I'm calling this 3 times, where I is 0, I go to the function, I'm passing 2. B is defined as 0, so B will be 0. And then C is still 0, because it just get defined. And then I'm increasing B and C afterwards, so we'll come into what we mean by this now. And then I add things up. So I'm adding B as, so here I increase B as 1, C as 1. Adding B plus C, 1 plus 1 is 2. And then I'm adding also the passed parameter, which here I'm passing 2. So I'm adding 1 plus 1 plus 2, it returns 4. Good. In the second iteration, what I'm doing is I'm passing again A is 2. All the iterations I'm passing A as 2. Then I go inside the function. I define B as 0, so it starts as 0. That makes sense. This is the regular thing that you might imagine. But the thing that may seem a little bit weird is how C is 1 here in the second call, while you just defined it, right? In fact, because you defined it as static, its value get carried on from the previous iteration, from the previous call. So you don't redefine, right? You know that by using static, you say, I'm using the old value of C, because you keep the place in the memory. And I will explain to you like by a sketch right now how these things happen. But the main thing is C is carrying on its own previous value because it has a single place in memory. It doesn't get destroyed. This is the main thing. Static doesn't get destroyed when you return. While B, it gets destroyed and recreated every time, right? So then by adding 1 and 1, so then you increase, so it takes 1 and 2, and then 1 plus 2 is 3, and then plus 2, which is A is 5, and then the same thing. So if we look into, let me see if I have a visual. No, I don't have this. So let me create it myself. So let's look into what happens in the memory, because that's important during iterations one by one. So I told you each time I go to call this function, which is called function now, it gets created on the stack, right? And then you create the variables. In the first iteration, I created B. A1 is already passed there as a parameter, so it gets created as well. And then I create C. And then I add things, so B plus plus, so B will be 1, C will be 1, and then I add 1 plus 1 plus 1 plus 2 is equal 4. That's the first iteration. Then, at the beginning, I told you once it's a local variable, so once you exit this function, everything gets destroyed, right? That's exactly correct, except for static variables. So static variables would remain exactly as they are. The hardware does not destroy them. So this is how they carry on their previous value. Everything gets destroyed except static variables. And then when you go to the second iteration, C would remain 1, while you define B from the beginning. So it's 0, and then you increase it. So it's 0. And then A will get the value of 2. And then now when you increase, this will be 2 and this will be 1. And the same thing, once you exit, you destroy everything except the C. Then in the third iteration, you go there. This will be created from the beginning. This is B. It has a value of 0. And then you add things up. So you increase, it's 1, it's 3. And then you add 1 plus 3 plus 2. So it gives you the 6 at the end, right? So this is exactly what is happening in the memory for static variables. Good. Is there a question? Does making a variable static affect how it can be modified outside the function? Yes, you cannot. That's an excellent question. Static variables are still local to their scope, right? So static is a word that does not change the scope of a variable. It changes its duration in the memory. So for example, here, if you try to say, I want to print if C, you will get a compiler error. Although C already exists in the memory, but it still exists within the scope of function. So if main is here, main doesn't have an exposure to C. So even if the variable is static, static only affects the duration, not the scope. Good? And that's an excellent question. So I hope that's clear now. Is there any other question? Would the function work the same if it was static int? Yes. So that's also a good question mark. So here we didn't initialize C. Remember, I told you that it's a very important. Okay, so that's a question that maybe I might need to try because it depends on the compiler, and it has two parts. The first part is initialization, right? So initialization means what? Means I told you before, each time you define a variable, you need to initialize it, correct? Static variables by default get initialized to 0, right? So you don't need to do the initialization yourself. This is the first thing, but they should work the same way. On the other hand, does it mean that when you go to the second iteration, it gets each time initialized to 0? No. So there shouldn't be any difference across these two applications by initializing C to 0 or not doing that, right? Okay, perfect. So if that's a very important concept, and there are a lot of tricks for this static stuff, right? Generally, people don't use static variable. So it will escape. Yeah, that's correct, Nicole, because it knows it's static. That's correct. It doesn't get defining it from the beginning. Okay, thanks. That said, some compilers may act weird. So it's not, but I'd say I don't want to confuse you. So yes, the general rule is that's correct. This is the syntax of C. If there is any question, please ask, because that's, as I said, it's a very important concept. So maybe one thing to add is usually people similar to global don't use static variables unless you intentionally want to carry on a state across different codes, which is uncommon a little bit in general programming, right? What if there is already some value stored in C? So box C, yeah. So I guess this you're talking about initialization. C has different rules of initializations. The general rule is a variable, when you declare it, like int b, for example, it doesn't get initialized to 0 by default. So you have to write this b equals 0. But we said that this rule does not, first of all, apply to arrays. If you remember, arrays get initialized to 0 by default. You don't need to write it. The second thing is this does not apply to static. A static, once you define a variable as static, it gets initialized to 0 by default. Good. Good. Okay, so that said, then let's switch gears to something else if there is no other question. I hope you are able to see the new slides. Let me just see the confirmation here before I start. Perfect, thanks. Okay, so what we have been doing in the past 2 weeks, right? So we started by writing our very first code, hello world, very simple example, and then hopefully also we went through the environment of setting up something, looking into a more scalable or professional way of writing code by having a unit testing, revision control, a very simple function, which is add function in lab 0. So hopefully this is done by today, or at least it will be done by today for most of you. And in the past 2 weeks, I intentionally started doing things only practical. So we didn't touch more about or in detail about the theory or the syntax behind what we write. Some of you asked, what is the range of a float? What is the difference between float and double? What if I exceed the maximum of int? And I intentionally delayed answering these questions in detail, right? Because I didn't want to start with the theory because it's more boring, to be honest. It's good to get your hands on, understand how to write a code, understand the whole environment. And then when you get the rule, you will now grasp it better than if you just started with saying, okay, this is how you write a for loop, this is how you write an if statement, this is like the range of a double or an int or plus plus, what does it mean if I put it after a variable or before a variable? All these kind of combinations would be hard to grasp at the beginning. But now, given that you are hopefully more experienced with coding in C, so let's look into some of the rules, because that's very important to have the general rules rather than only being able to write some pieces of code. Again, this differentiates an engineer from someone who is just like taking programming as a hobby, right? Good. So let's take what we covered in the past 2 weeks. So this is the main purpose of this lecture, and maybe the coming lecture is to go back, reflect a little bit of what we wrote, and understand really what are the concepts behind it. What are the rules? So variables at the beginning. So variables are something you define such that you are able to use within your code. Makes sense. Int b, int x, int y, double z. And then a variable can have any name as far as it's a legal name, right? And here we kind of get the general rules of defining a variable in C. For example, it has to be a sequence of letters. It has to start with a letter, not a number. It can have a combinations of digits and letters or underscores, but you cannot use any special character. And it has a maximum length of 31. So you cannot define a variable that has a length more than 31. This rule might apply to some operating systems and might not, but keep it as a general rule. For example, don't define a variable that has like a line length. This is not even readable, even if it's allowed. And some important thing in C that does not apply to other languages or other programming styles, maybe it's not a correct name to call them languages, like something like MATLAB, for example. Variables in C are case sensitive. And this is a general rule in C. C is a very strict language, as we have seen before. So small x versus larger x or capital X, these are two different variables. And sometimes this creates, if you are not aware of this, you might define a variable in a way, and maybe 1,000 lines later or in a different file, you tried to use it, but you forgot how it's written, whether it's capital or small. And there are some conventions in defining variables in C. For example, don't define a variable that begins with a capital letter unless it's something that, for example, like a structure or an array name. So just get a convention, right? Most variables should start with a small letter, but that's not a syntax rule. It's more of a convention. Any variable must be declared with a type. And this is also something that is different from other languages. For example, in Python, the one that you are familiar with, you can start directly by using a variable. You say x equal 2, and then the language, because it's less strict one, it's an interpreted language, it will know that you want x, for example, to be like an int or double. C, because it's strict, you cannot say x equal 2. You have to define the type of this variable. Good. The type indicates multiple things. We used int x, double x. What does it mean? First of all, it tells you the type. This is why like we have the name type of the variable. You want it to be integer, you want it to be floating point, decimal, etc. Right? This is one thing. But also it tells you the width that you want to store this variable in the memory. Because, for example, we said int are 4 bytes or 32 bits. So they occupy 4 bytes in the memory, while characters are a single byte. We will see right now all the width in the memory, but this is something that the type also indicates. Once you define a certain type, you know how much memory you are going to occupy for this variable. And also, what operations are possible for that variable, because not all variables are possible to do operations on them, right? For example, division in integers is different than division for floats in C. Adding integers is different than adding characters or floats. So like doing the mod operation, different operations have different rules based on what is the variable type. Okay, before picking questions, let's look into some examples, right? One type is character, and this is the simplest type in C. If you define something as a character, it only occupies 1 byte in the memory, right? And then the way we will see right now how to write a character, but let's look into some of the common types. Int are either 16-bit or 32 bits, but most of the time right now they are 32 bits by default. And then we have some variations of int, and some of you asked about this, for example, signed or unsigned. We have what we call short int. So this occupies less space in memory, and we have what we call long int. 16 versus 32. Like short int is usually 16 or 2 bytes, and long int is 32 bits or 4 bytes. A float, as I said in the last lecture, it's a single precision floating point. Double is a double precision, so this is 32-bit decimal, and this is 64-bit. And then also we have what we call long double. So it's extended precision. If you want like a double value that goes beyond the 64-bit, this gives you the long double, allows you to have more values, but at the same time, it occupies more memory. And then another variation of all number types is signed, unsigned. For example, I can define an int as to be signed. All these variables, like all these types, int, float, double, are signed by default, which means they have positive and negative value. But once you say they are unsigned, so this is the default value, right? Once you have unsigned, it only gives you the positive number. So if you say unsigned int x, you cannot say x equal -1. It's an unallowed value. Good. Some of the arithmetic operation. Let me pick some questions if you guys have questions. Are underscore uppercase letters preferred when defining variables? For example, this variable or this variable. Both are allowed, Benjamin, but I would say try as much. Okay, this is a personal preference. So professionally, I don't prefer the underscore much. I prefer the first one, but again, it's a personal preference. How many bits is long double? That's a good question. This is a machine dependent, right? In most cases, 128 bits. Right, but it's machine dependent. But take it maybe as a general rule, it's 128 bits because you concatenate 2 registers together. Everything is going back to the hardware. So most of our modern machines are including 64-bit registers, which means one variable can be held generally in one register. But for the long double one, you can concatenate 2 registers together and gives you a variation of 128 bits in general, right? Okay, let's look into some of the arithmetic operations that we have been doing before. So unary operators, we will come into these for now, addition, subtraction of only a single variable. And then binary operators that would require 2 operands to operate on, like addition, subtraction, multiplication, division, etc. A general rule, and this is something that might be very confusing in C, and sometimes I use this trick in exams. I'm just trying to reveal myself here. So if you divide an int by an int in C, it only gives you the int the int result. So it ignores any, it truncates any decimal operation. For example, if I'm dividing 5 by 2, it doesn't give you 2.5. It truncates this and only gives you 2. Why? Because int divided by int in C, it returns int. And as you have seen from our last lecture, if you are getting a float value in an int value, it only takes the decimal value itself, not the fraction, right? This is the reminder that we have used. Remember, we have used this to determine odd versus even before. I guess this was our second lecture. So it gives you the reminder or the modulus of a division operation. For example, if you are doing 18 mod 4, so you divide 18 by 4, this gives you what, 4, and then a reminder of 2. So this will give you 2. Okay, so some kind of complicated expressions that are added together, and what is the precedence and how things are being calculated, right? So assume I have something like this. I would say x equal this, right? What do I do? I guess most of you will be already knowing this from Python, because the precedence constraints in any language are almost the same, right? What we mean by precedence constraints, and you guys know this from math, even in school, is you start from the left. If you have any brackets, you calculate this first, but then division and multiplication takes the high precedence, right? So if I'm doing this, you have the division, multiplication, have the same level of precedence, so you start with them. So here you would divide first, and then do the multiplication, this first, second, and then at the end, do the addition, right? So what is the general rule? Here is the general rule. Here is the table for the precedence. The first thing is, and this is, as I said, I don't think it's new for you. So if you know the rules from Python, it's almost the same, right? Or even in your calculator, right? So in math, most of the precedence constraints are kind of standard across different programming languages. You start from the brackets or parentheses, and then you have the second most important one is you have the pre-increment posting, like the not the post one. You have the pre-increment, pre-decrement, and we will explain what does it mean now. But we had it in our for loops, if you remember before. And then addition, subtraction, and then this is the not operation. We'll come into this, but these are so these are unary. So why these have the high precedence, right? Because they only take a single operand, so they don't operate in two operands, right? And then afterwards we go to what you know. Multiplication, division, mod operations are higher than addition, subtraction, and then you do any kind of relational detection, like larger than, equal, smaller than or equal, not equal, and we will discuss this also in detail now. And then you have the logical AND. So you're trying to do, and we have done this in an example in a lecture, but again, I will touch it with more examples today, is you have two expressions, two conditions, and you want to take the AND of both, right? Or if you take the OR of both, you say condition 1 or condition 2, if they are correct, I do something. Usually these appear within an if condition or something that would require while loop, for example, something that would require condition decision. And then last, you have the assignment. In C, there are some kind of weird assignments. The first one is pretty easy, it's known, right? But this one is plus equal. So what you do for the plus equal is, for example, I say x plus equal 2. This is equivalent, and again, we will touch on this right now. So we have x, this is exactly that. So it's just a compact way of doing an addition and then assignment for the same variable, right? And then the same thing for minus equal, multiplication equal, division equal, mod equal, and then the comma, but we're not touching the comma for this course. You don't need to operate with the comma operator into SH4 at all, right? Okay, I see that there might be some kind of discussions or examples, but I don't want to look into the questions until I give you some examples, because they will clarify all these rules, right? Assignment operator. So assignment, you basically assign the right-hand side to the left-hand side, correct? So you can read it as this variable is taking the value of this expression. So you have to calculate the expression first, then assign the value to this variable. So for example, if I'm saying y equals 7 multiplied by 3 minus 8, you calculate the values 21 minus 8, then y will get the value of whatever it is, like 2 and 13, I guess, right? Something like this. So you calculate the expression and then you assign the value. This is for the assignment. And then compound assignment, the one that we covered on, I told you that x plus equal is completely equivalent to x equal x plus 3. So it's a different way of writing things. The same thing for minus equal, and then division equal. So you divide y by 5 and then assign the value to y. And then multiplication equal, the same thing. You multiply the variable with the immediate value you have or the expression you have on the right, and then you assign it back to the same variable. And then the same thing for mod. Good. Now, okay, given that we have some examples, let me look into some of the questions. Question, what are the plus and minus at the top? These are the, okay. Like the sign, that's correct. Okay, I would say that's correct. But also we had the pre-increment, post-increment, and pre-decrement, post-decrement, but we'll touch on this right now. How can you do division in C, not end division? Just a regular division, like you have X divided by Y, for example. What is the difference between signed end and end? There is no difference at all. End by default is signed. Okay, let me see if there are other questions. Oh, like this thing is not a division. This is a comment, right? So you, like, this is not an arithmetic operator in C, right? This does not exist. When we did for loops, we did I++. What is that? I will come into this in next. Sarah, I will discuss this in next slide. So let's move in. Do you have to make 5 and 2, 4? Yes. So Nico, that's an excellent question. If you have an immediate value, so previously we said 5 by 2 will give you 2 in C. Why? Because 5 is end, 2 is end. What if I want to the correct value? So you have to divide float by float. So to write it as an immediate value, it has to be like that. And it will give you this value. Or you can say something like this: float X equal 5, float Y equal 2, and then you say float Z equal X plus Y. This also, because given that this float by float, it will give you, it's like I'm doing it the other way around. It will give you the correct float value. This is called integer division in C. If you divide end by end, the value will be end, and this is the only restriction we have. Could you do float? Oh, Daniel, that's a good one. This is casting, but we didn't come. We will come into casting right now. So you can do this, but in fact, what you wrote will not give you the correct value, but we will see, right? Okay, so there was this question, I guess, from Sarah about what is pre-increment, post-increment, plus, I++ that we have done for the for loop, right? So this operator in C, you can either put it before the variable and it's called, for example, we're talking about the increment now. It's called pre-increment, which means increment this both means increment the variable by 1, right? You increment is just adding 1 to the variable. But both have different effect. Pre-increment, you increment the variable before calculating the expression because it's pre-increment. It has the highest precedence, right? So you start with it. On the other hand, post-increment, you calculate the expression before incrementing the variable at all, and at the end you increment it. So let's take some example. And the same thing for the decrement. So, okay, here. Let's see first what is possible, what is not, and then I will explain some examples. So this is possible because this is equivalent to say I want x to be x plus 1, but it's post increment, so it's allowed. Why this is not allowed? Because you cannot increment. So this is an expression, right? The increment, and the expression, the result has to be placed in a certain place in memory. Immediate values like 5 are just immediate, like constants. They don't have a space in memory. So where, after I increment, where should I put my variable? There is no memory allocated, right? This is why it gives you an error, because it's like saying, writing in C 5 plus 1. But that's, what is that? Like, this is an expression that has to be taken somewhere, right? This is also something that is not allowed, because you cannot just add an expression like that. You have to add a variable, right? So what you can do instead is to say y equal x plus 3 and then y plus plus, right? Because also post increment cannot be done within an expression that would require calculations. So it's only done in variables. Why you'd ever put it before? We will have examples for this now, Nicole. Question, Daniel, could you do float? Okay, this was the question that I answered. Wouldn't that just give you 2? The integer division happened first. Okay, yeah was like kind of answering Daniel. Please, guys, if you have questions, put it in questions such that I only look into them. Thanks. Okay, so Nicole was saying why I would ever have this pre-increment, why I would like to increment first. Let's see some examples, right? Assume I have a piece of code where I define 3 end variables, I equal 1, a equals 0, b equals 0. And then I would say a equal plus plus I, right? So what would happen at the end if I want here to print f a and I? What I would see, a is clear because a will take the value of I incremented by 1, so a will be 2, right? But what about I? I is incremented before doing the I is incremented before assigning the expression. So here we are doing two things: assignment, which is this, and the increment operation, which is this. If you do it this way, then you do the increment first, then the assignment. So I wrote it in the wrong order. So I will be 2 first, and then a will take I, so it will be 2. Does this make sense? Now, if I do that, I here is 1. So again, I have 2 operations, the increment and the assignment. But this is called post increment, so it's done second, and this is done first. So here the order is different. Here is the order is by b equal I, which is still 1, and then I plus plus, which is going to be 2. Does this make sense? So you do, it depends on what is the order of the operation. Pre-increment happens first, post-increment happens second after the assignment, right? Okay, Sarah, could you only increment by 1, and if it's more than 1, I guess you would do x plus 2. That's correct. If you are available, could you get some help with my lab 0? Okay, that's a private message. Let's look into this now. Sorry, question 2 and 1. Yes, okay. Relational and equality operators. So we have done the post increment, pre-increment. Let's look into some of the conditions in the if statement. I want to check whether there is an equality, inequality, larger, like greater or equal, smaller or equal, etc. So if I say a is larger than or equal 0, then I'm checking something, right? Like this will give you either true or false, right? And this is equality operator. So you check whether this will give you, we tried this before, if you remember, by saying if the input we have read, or I guess the I that I'm taking, if I remember correctly, was 2, sorry, what is that? 2 equals 0, 0. That means it was even. Otherwise, it was odd, right? So we have done this before. So you are checking here, you are checking equality, right? So we also want to check the not. So these are called logical operators. And I guess also you guys will have the concept of this in the digital design course if you're taking it. So it's like having a logic gate. You're doing a negation, you're doing an and, an or. So what does it mean? If I'm doing a negation for a variable or an expression, I'm just inverting it. So for example, if it was true, not expression will give you false. If it was false, not expression will give you true. So it's as simple, right? Here, for example, if 7 is less than or equal to 6, that's false, right? But I'm doing not, so this will give you true, correct? I guess that's very clear. So this is a single operand, so it's a unary operator. Logical operators that takes 2 operands, we have and or. So for and, you have 2 expressions. So I have an expression 1 and an expression 2 here. If this expression is true and this is true, the and will give you true. So you say, I want both to happen on the same time to have a true, right? On the other hand, for or, you are saying, I only need to check if one of them at least is true. So if expression 1 is true or expression 2 is true, then it gives you true, right? This we usually write in math, but that's not possible in programming in C. So what you can do instead is, let's see how we can write this in using the and or expressions. I want to check if A is larger than or equal to 2 and less than or equal to 6. I just said it, so it's and, it has to be and, right? So you need to split these two to say, is A larger than or equal to 2? And is A is less than or equal to 6? This is how you would write it, right? So it calculates both expressions for you because these are two different checks, and you use the and operator. Good? Let's check. This is like a question. When is the following true? If A is larger than or equal to 2, or A is less than or equal to 6, when you think this is going to be true? Three to 5. Is that the case? Or 2 to 6, it's the same thing. Is that the case? It's the case only for the and, right? Because you are checking, is it larger than or equal to 2, and it has to be less than 6, right? But this expression here, because I'm using the or, let's take an example, right? What if A is 10? If A is 10, this expression is true, correct? Because A is larger than 2. And because it's or, whatever this value is, I don't really care. Even if it's false, I still get true, right? And that's the importance of understanding or versus and, right? You got it? Good. Thank you. So this is just the summary of the rule. If you have X and Y and you're doing X and Y, so if it only gives you true if both are true. In logic design, this is called AND gate. And this is OR. So it only gives you false if both are false, right? Good. Okay. So, okay, we have already touched this. Let's look into some examples to see what we want to do. So we talked about types and variables and declarations, right? So let's see what are some of the possible value declarations and what are some of the incorrect ones or syntactically incorrect ones. So I'm defining a variable as an unsigned int, and this is day, month, and year. One note here is, if you are assigning a variable to be a day, in fact, you can call it X, right? But having a meaningful name for your variable, this is a very important skill. Don't call it, I don't know, last variable or death or like YYY or Y1, Y2, Y3. Have some meaningful name for your variables, because first of all, it's a professional way. For example, if you go for an internship and you are giving your senior colleague in the team like a program that is written all in X and Y's and X1, X2, X3, it's very hard to debug. So having a meaningful name. Second is also, in addition to debugging, it's good for your own use afterwards. So usability, if I want to embed your code in a larger code base, it would be very useful. Good. And then because these will never have negative values, so it's safe to define them as unsigned, right? Here, it might still be correct that you can define these as int, but it's not a good idea, because this is allowing the user to input negative values, right? Assume that you are defining these variables and you are taking them from the user. For example, please enter your date of birth as year, month, day. If you define your variables as this, the user will get an error if he tries to enter a negative value. But if you define this as this, you have to take care that you do this conditioning yourself. The compiler will not do it for you. Good. Here I'm defining two float variables, but you cannot do something like this. Can someone say why it cannot do something like that? Why this is incorrect? Any number. What is any number? No proper sign. I missed why you unsigned in for this. Can anyone explain? I'll come into this, Safi, now. Illegal characters, correct, Danny. So here, you cannot use special characters in variable's name, right? This is not allowed. So syntax error, right? Another question is this one. other than, so let me re-say what I said here because someone missed it. So what I was saying is, if you define this as unsigned, but the user is entering something like day equal, I don't know, -12, he will get an error because this variable is as unsigned, so it cannot get negative values, right? So it plays as a guard for you against improper user input values, right? While here, they can be positive or negative, correct? Let me then ask another question. Here, there is also another syntax error in this line of code. Why it's incorrect?
It's not a colon.
Yeah, there is no colon. That's correct. Let me first make sure. Okay, someone has music in the background. That's relaxing, but I would say I appreciate you kind of mute your microphone. Okay, so there is a semicolon missing here. So you can define multiple variables in the same line in C, something like that. They are separated by colons, but you have to end any statement in C by a semicolon. Good, thanks. What about this one? You can also, we said here you can define multiple variables separated by colons, but you can also initialize them, right? So here, I can write this in 3 lines by saying int I equals 0, int m without initializing it, and then int j equal 1. But in a single line, if all of them are of the same type, you can do that, right? Good. I guess there is a question here. So is there a point in defining a variable as signed int? Isn't that the same as just send? That's correct, Danny. Cannot use, that's correct, Karina, thanks. Simple statements, some expressions. So we will start putting these kind of expressions together. This is a valid one in C because it ended up being a equal a plus 1. So this is already stated. We can also do this very simple. We have done it before. This is also possible. This is possible, which means you do nothing. Like basically it's an empty statement. It's a NOP operation. I can also call some function, this function calling, and we have seen it before. All of these are valid expressions in C. This is invalid. Why? Again, I'm missing a semicolon here. This is also invalid. That's a wrong one. Good. So it's like giving you some examples of what you can do and what you cannot do. So we also got the multiple examples of if-else statements, right? But we didn't kind of revise. I asked you to look into the Python revision videos I posted on Avenue to just like make sure you understand the concept behind an if statement. But let's quickly go through it. What we want to do an if-else condition is like a flow chart. You have a condition. If it's true, do something. If it's false, do another thing, correct? So this is what you do. You have your condition here. This is the if path, and this is the else path, right? So here I have action 1, which happens only if the if is correct. And you have the action B, this one, which happens in the else statement, correct? So you can also only have if, right? Which is if the condition is true, do something. But if the condition is false, you basically just don't do anything. You go to the statement directly after the if. So you don't have an else, right? So some examples. Here, if I'm checking if x is less than y, then I'm doing some calculations. And then if in this case x is larger than y, I'm doing something else, right? Which means what? This means that z will always take the value of, can someone imagine what's going on? The min, exactly. So it's taking the smaller value because if x is smaller, I'm assigning d to be x. And if y is smaller, which is the else, I'm assigning. So here I'm just calculating the min, right? I can write this exactly in a different way, right? I can say I'm going to initialize z with any of them, y or x, and then check. If the other one is smaller, then I'm going to change the assignment. Done, right? This also tells you, and you will see this a lot in the lectures, you can write your code in multiple ways, right? So doing exactly the same functionality, but using different syntax, because languages are rich. Rich means you can express the same algorithm you want in multiple ways, right? Good. So we have seen if else, but we didn't see if else f, etc., correct, right? So, or nested f's first. So, for example, in one of the questions you have in lab 1, you are asked to determine this Pythagorean sides of a triangle, and you are asked to have a nested f, right? So, which means f inside an f inside an f. So, how nested f's work, right? You start with the parent f. So, I call this f1, right? Inside it, you might have any expression, a valid expression in C, including even another f, right? And this one can has if and else. This is an else, which is else 2, right? And then at the end, you would have the else of the 1, right? This makes sense? So if we write this in this way, it would be if 1, this is condition 1, do something, else do something else, which is going to be B, right? And this is action. Yeah, this is not a specific action yet. And then inside the f body here, I'm writing another f, which I'm calling f2, taking condition 2. And then if this is true, you do action C. And else, if it's not true, you do action D. So this if else is inside the block of this f. This is why it's called nested f, right? I hope you guys remember this from Python as well. So here is an example. Like I have a big F here, and then this F is having some nested Fs. So you have an F and else, condition 1. If condition 1 is false, you skip all of that, and then you execute this statement. But if it's true, you start going through condition 2 and statement 3. In other words, statement 3 will only be executed if, can someone imagine what conditions need to be satisfied to execute statement 3? True. Yeah, but what conditions? It's condition 1 and condition 2, Karina, right? Yes. So you have to have this as true to come in inside here, and then have this as true to come inside here, right? So I can try to write this in a different way, as we said. Statement 3 would require condition 1, condition 2. But then, so what we have done is we just removed these brackets. So the only change from this to this is to remove these brackets of the F, right? Of these braces. Why? Because if else is a single statement. Someone already, I guess, raised this point in the last lecture, is saying sometimes if you have a single statement in F, you don't open braces or brackets, right? The reason is it's single statement, so you don't need the block of code. And if else is seen by a compiler as just a single block of code, so you don't need these in fact. That said, you are highly advised that as a good programming practice, anytime you have an if or else or while or for or whatever, open these braces, right? Even if it's a single state. This is a good programming practice. Good. But here we are trying to cover all the rules to make sure you guys get it. I know that this lecture might be a little bit boring. It's a little bit boring to me as well because I like this handy-on stuff. But it's important to cover the basics to make sure once you have a problem in your code, go back and check what are the rules. It's like looking into the manual of a language, right? Okay, we covered the nested if else. So you can have the if. So previously we had all the nested ifs inside the if, but in fact you can also have them inside the else, right? So the same thing. Which means here, if we look into statement 3, this gets executed when, right? It gets executed if condition 1 is false, right? So it's not condition 1, and condition 2 is true, right? So now we changed it a little bit. Let me look into questions. Should we always omit for nested if or no? No. What I was saying, Jan, how is you should always keep the braces no matter what, right? The rule that I was just saying as a syntax in C is if you have a single statement in your F body, it is correct to remove the braces while in fact you are not recommended. And if else as a whole is considered a single statement, so this is why we omitted it, okay? Okay. So good. So we also covered repetition, while, do, while, for, and we did all the practical examples there using the same, like the same program. We wrote it in different ways. So let's look into the general rule. For for, you have 3 pieces at single line. You have an expression, which is the initialization. You have the condition, which tells you whether you should execute this iteration or not. And you have the expression 2, which is the increment. Right? This is the general expression for a for. How to visualize this? You look into expression 1, which is initializing, and then you have the condition. If the condition is false, you will not execute your loop. Otherwise, if it's true, you execute the body of the loop and then do the increment for expression 2, and then go back, check again condition 1, as far as you have many iterations that are possible, right? An example that we have seen multiple times. This is okay. Then let's pick some kind of alternatives to see if we understand, right? So here, very simple one. I'm just iterating 20 times and printing a star, right? On the other hand, here I'm starting from 1 instead of starting from 0, and I'm changing. So the only change is this one and this one. Let's see what would be the difference. Then finally, I'm doing the other way around. So I'm starting from 20 and then decrementing and then doing less than or equal, right? So let's see. So here, okay, there is another one. So let me just think together. What do you think will be printed here? In the first one, I'm printing stars. If you try this on your own, can you think of what would happen? First of all, how many iterations I'm executing this printf? The first one. Oh, what is the time? Let me just close this screen here. Ah, okay. Okay, so we passed the time by 10 minutes. So that's very interesting. Okay, so let me say the following. So we will stop here then. And sorry, everyone. I guess you might have other lectures as well. So we'll stop here and continue next time. Okay, and thanks for reminding me. Thank you. Okay, see you on Tuesday then. Thanks, everyone. Bye bye.